Okay, hello people. This is homework number 15, and there's going to be a solution set which probably consists of 2 or 3 video segments. Now remember, homework number 15 is coming from section 4.3 in the book, which is relatively long, so I broke it down into 2 parts. This is part 1, where I discuss the half angle and double angle formulas, and then we do sum and products in the next homework segment. Okay? So let's start with number 3 here. It says that find sine 2x, cosine 2x, and tangent 2x, assuming that you know that sine of x is 5 over 13 and x is in quadrant 1. Okay, so it is obvious that we need to use the double angle formulas. For example, what we want, we know, let's do it like this. We know that sine of x is equal to 5 over 13. 5 over 13. And x is in quadrant 1. Okay, so what you want to do is, what is sine of 2x? I did this thing in class, but I'm going to repeat it here. It's going to be 2 sine x cos x. This is the formula that is coming from this section. Now, we know sine of x, that was given to us. Okay, this is 5 over 13. There's no problem. But the question is, what is the cosine of x? Now, remember, from basic trig identities, cos x is plus or minus root of 1 minus sine squared x. Now, the choice of plus or minus depends on this statement, because it says x is in quadrant 1, and in quadrant 1, just go to the trig circle, cosine of x is positive, okay? Therefore, cosine of x is equal to square root, or plus square root of 1 minus sine squared, and we plug it in, plus square root of 1 minus 5 over 13 squared. Please do the arithmetic yourself. This is going to be plus, the top is going to be 169 minus 25 over 169, and this is root of, up there we have 144 divided by 169, which is 12 over 13. Okay. All right, so this number here is 12 over 13. In other words, sine of 2x is 2 times 5 over 13 times 12 over 13. I'm perfectly happy if you left it like that, but believe me, the answer in the book is not going to look like this. They probably simplify it, and incidentally, they're not going to be using calculator. I'm sure they're going to leave it like this. Okay, let's do the next one. Same problem. This is problem number 13, number 3, as I mentioned. So let's do the next one. I'm going to use a different color here. Cosine of 2x. Now we know from our double angle formula, one way of writing this thing is 1 minus 2 sine squared x. I want to remind you that this is the same as sine of x squared, so don't get confused. These are the same thing. Okay. So 1 minus 2, and we were given already 5 over 13 squared. And this is 1 minus 2, 25 over 169. So this is 1 minus 50 over 169. And this is 169 minus 50 over 169. And that is, what is that, 119 over 169. Let me point out to you that on the test or on the quiz, if you stopped here, unless you were specifically told to simplify as much as possible, I don't require that you go through this. However, I strongly suggest some of you, do the arithmetic here, because there are little things that you may be doing wrong in basic arithmetic that's going to surface if you follow this and realize that, ooh, I'm not getting the answer in the book. Therefore, what's going on? Maybe you're doing something fundamentally wrong. Okay, but as far as I'm concerned for the test or the quiz, unless you were specifically asked to get cosine of 2x, you can stop right there. Okay. Let's do the last part here, which says different color, which says find tangent of 2x. Well, tangent of 2x is, well, for example, one way is to do that is basically using the formula that we learned in this particular section, which is 2 tangent of x divided by 1 minus tangent of x squared. Now, you found tangent of x. Well, actually, you find sine of x and cosine of x. So essentially, you have found tangent of x. This was given to you. It was 5 over 3. This was given to you as 5 over 13. This you calculated, and it came out to be cosine of x. You work it out. It's 12 over 13 right here. See that? 12 over 13. So tangent of x is 5 over 12. So as I said, for my course, it's okay if you just put this thing in here. 2 times 5 over 12, 1 minus 5 over 12 squared. As I said, I urge you to go ahead, do the arithmetic, and compare it with the answer in the book, because basic fundamental mistakes that you may have done throughout are going to pop up, and at least you know that something needs to be done about it. Okay, this one is number 4. You're told that tangent of x is equal to minus 4 over 3, and x is in quadrant. What is that? X is in quadrant 2. Okay. So first of all, what does this tell us? If you're in quadrant 2, this is quadrant 1, quadrant 2, 3, and 4. Notice in quadrant 2, sine of x is positive and cosine of x is negative. So just remember that. Okay. So now we're going to go. Let's go and find the a. Let's find sine of 2x. This is what we're supposed to do. So this is 2 sine x cos x. Okay? So there are different ways of doing this problem. Here's what I'm going to suggest. Okay, so you look at this, and it tells you that basically you have a right triangle. This is the angle x. The opposite is 4, and the adjacent is 3. Now, you don't have to worry about this negative sign. You will, based on the observation that you made here. Okay? However, it can get you into trouble, because I noticed that some of you will write -4 or -3 or something like that, and eventually it gets you into trouble, and you probably don't know what happened. Now, if you have a right triangle like that, this is 5, okay? Therefore, sine of x is equal to opposite, which is 4, over hypotenuse, which is 5. And notice that sine of x is positive, so you don't change the sign here. Cosine of x, what I mean, you don't change the algebraic sign, is adjacent, 3 over hypotenuse, which is 5, but you know that cosine of x in this quadrant is negative, so you need to put a minus there. Now, if you do it some other way based on whatever you think is right, and you get the correct answer, I have no problem, but I personally don't like the idea of the people putting minus here and minus there and trying to work out the problem. I don't care. If you get it right, maybe what you know is working. 4 over 5 times minus 3 over 5, and this is perfectly okay to stop. Okay, now part B, or part B says find cosine 2x. Now we can do it different ways. For example, we can do it as 1 minus 2 sine squared x. Or we can do it as 2 cosine squared x minus 1. Or we can do it as cosine squared x minus sine squared x. These are all saying the same thing. These are all the same thing. You can use whatever you like. There's going to be 1 minus 2 Now, if I use this as sine of x, 4 over 5 quantity squared. Okay. And finally, part C, it says find tangent of 2x. Okay. Now, tangent 2x is 2 tangent of x plus 1 minus tangent squared x. And in fact, tangent of x was given to you. It was given as minus 2 times minus 4 over 3. This is something that was given to you, okay? And then divided by 1 minus 4 over 3 quantity squared. Perfectly acceptable to me, okay? Not acceptable to the book. Okay, so let's move on to the next problem box. Again, I did some of these things in class. Let me see, let's get through this. Okay, good. So, okay. So I'm going to do number 11. And this one I did in class, sine of 4 to the x. It says reduce the power to 1. Now, let me bring up the sheet that I'm going to provide to you on the quiz. Let me see now here. Let me bring this up. Okay. These are taken directly from your book, and this is the sheet. These are the two sheets that I'm going to give you. This from 4.2, which I already gave on the quiz number 6, by the way, or quiz number 7, right? And this is what you're going to be testing on this coming Wednesday. Notice that half angle formulas, of course, these are the half angle formulas. However, down here it says formulas for lowering power. So it's obviously these things that I'm going to be using as seen fit and necessary. Okay, so let's go ahead here. I did this thing in class, but let's do it again. So what I'm going to do is sine to the 4x. I'm going to write it as sine squared x to the power 2. And inside of this, right here, I'm going to write this 1 minus cosine squared x to the power 2. Now this, you can either FOIL it or use the identity that you were supposed to have memorized all these years, I squared minus 2a squared minus 2ab plus b squared. I leave it to you, whether appeal to that or just go ahead and FOIL it. So it's going to be 1 minus 2 times 1 times cosine squared, and then plus cosine squared x to the power 2. The problem if I do it at this stage is that you still have cosine to the 4x. So what I'm going to do instead of foiling that, let me cross this out. I'm not going to foil it. I'm going to reduce this power cosine squared x to 1, and that's using the formula that I just showed you. So it's going to be 1 minus, now this thing, just look it up in that formula. It's where is it? Right here. See that cosine squared x equal to 1 plus cosine of 2x over 2. So it's going to be 1 plus cosine of 2x divided by 2 quantity squared. Okay, so let's do a little bit of cleanup here. So this is 1/2 minus, I hope you know that this is minus 1/2 minus 1/2 of cosine of 2x. These are basic arithmetic skills. Okay, so it's 1/2 plus that, except that there's a minus sign here, so that's why these are both becoming minus. Yeah. Uh, oh, I'm sorry. This was not 1/2. This was a 1. This was a 1, right? Yeah. Let's clean it up now. So 1 minus 1/2 is 1/2. Minus 1/2. Cosine of 2x. Cosine of 2x to the power 2. Notice that the degree went from 4 to 2. However, that's a cost, and the cost is that the angle has doubled, which is okay. So now once again, now this is what we're going to use. 1/2 quantity squared minus 1/2 times 1/2 times 1/2 cosine of 2x plus 1/2 cosine of 2x quantity squared. Notice that this is what I did. Do a bit of a cleanup here. So this is equal to 1 over a quarter minus 1 over 8 cosine of 2x. That's these three. Okay, that gives you that. And then plus 1 over 4 cosine squared of 2x. Now, this is still power 2, but the same trick that I used to reduce the power of 2 using the double angle formula, I can use it again. In other words, we know that cosine squared of anything, for example, here is 2x, equal to 1 plus cosine of double of that thing, 4x divided by 2. This is the same formula that you saw here. See right there? It's this one, except that instead of x, I have 2x. If I put a 2x here, this becomes 4x. And so this is equal to 1 over 4 minus 1 over 8 cosine of 2x plus 1 over 4 times 1 plus cosine of 4x divided by 2. And there we are. No longer we have a power of cosine, but at the cost, the angles of 2x and 4x have been introduced. As far as I'm concerned, this is good enough. You can leave it like this. But the answer in the book, probably they do an algebra and clean this up. They write in a different form. Let's go and do the next one. Number 12. This is almost the same as the other one. So we're going to write this thing as cosine squared x to the power 2. And inside the parentheses, we can do it 1 minus sine squared x, the fundamental, the fundamental trig identity that you should always know. Okay, so now we're going to rewrite this thing using the double angle formula. 1 minus, if you look at the formulas that we have in this section, the one that I'm using is the middle box on the left. So it's going to be 1 minus sine squared x is 1 minus cosine of 2x over 2. So this is going to be 1 minus cosine, 1 minus cosine of 2x over 2 and quantity squared. Okay, these steps you can see that they're identical. They're very similar to the other one. 1 minus 1/2 plus 1/2 cosine of 2x. See, I'm doing this minus that, but there's a minus sign. There's a minus sign sitting in front of that, so that's why these signs switch. If you're still confused, please go ahead, write it your own way, and make sure you get this. Okay, so it's going to be 1/2 plus 1/2 cosine of 2x quantity squared. So here I'm using the foiling it, or using the identity a plus b quantity squared is a squared plus 2ab plus b squared. So that's going to be 1/2 squared plus 2 times 1/2 times 1/2. I just realized something Pretty bad. Pretty bad. I am missing. I am terribly sorry. Here, here, I'm missing a factor 2. See that? This should not have been. This should not have been 1/2. It should have been a 2. Terribly sorry. That means this thing becomes a 1/2. That thing becomes a 1/2. Okay. That means this is a 1/2. So the answer in the previous problem, instead of being 1/8 of that, it's 1/2 of that. And I'm terribly sorry. I just noticed it because the same thing will happen here. Here I picked it up correctly right there, but then I realized that the other one I didn't do it correctly. So it's going to be 2 times this times that, and then finally plus 1/2 cosine of 2x squared. Clean it up, 1/4. Now notice that again these two cancel each other out. You get 1/2 cosine of 2x plus this thing is 1/4 cosine of 2x squared. Now notice that this is very much exactly the same as that, except that this sign became plus instead of minus. Okay, once finally I have to get rid of this. And remember we use our double angle formula. Cosine of 2x is equal to 1 plus cosine of 4x divided by 2. So this is equal to 1/4 plus 1/2 cosine of 2x. There's nothing I have to do with this because this is already power 1 plus 1/4 of this, which is 1 plus cosine of 4x over 2. And if I, yeah, that's pretty much it. You can see that this is exactly like that, except for this sign. This sign over there was minus. This sign over here is plus. And of course, there's no way for us to know that. You have to do it, work it out. Number 13. Cosine squared x, sine squared x. I think I also did this thing in class. So we know what to do with this. It's 1 plus cosine of 2x over 2. And we know what to do with that. It's going to be 1 minus cosine of 2x over 2. This is 1/4. 1 plus cosine of 2x times 1 minus cosine of 2x. And if you FOIL this thing, you get 1 minus cosine squared of 2x. Remember, in class I said that this is something like this, a plus b times a minus b. You're welcome to FOIL this thing for the rest of your life, but you also know that it's a squared minus b squared. Good. Now finally, you have to get rid of this power. We use the double angle formula again. So this, let me write this thing one more step. 1/4 minus 1/4 cosine squared of 2x. We have to get rid of this using double angle formula. Minus 1/4, and this was 1 plus cosine of double the angle. This angle is already 2x, so it becomes double of that, becomes 4. Yeah, 4x over 2. Okay, and this is perfectly acceptable for me. You can leave it the way it is, but the answer in the book is not going to be like that. They have simplified it. Number 14, last one from this group. We have cosine to the 4x sine squared x. Now, let me remind you that we already did this. So I'm not going to repeat it. So I'm just going to write down the answer. We already did that. And let me see, which problem was it? That was already number 12, okay? So it came out to be this guy, 1/4. So I'm going to copy that. Can I copy it? Oh, I guess I have to go right. 1/4 plus 1/2 cosine of 2x. So it's going to be, it was 1/4 plus 1/2 of cosine of 2x. And I believe the other one is 1/8 Was that 1 over 8? Yeah. See that? 1 over 8 times 1 plus cosine of, is it this one? Yeah. 1 plus 1/8 of 1 plus cosine of 4x. So let's go ahead. Plus 1/8 times 1 plus cosine of 4x. Okay, that's good. So this is that term. Now this guy, we can write it as 1 minus cosine of 2x over 4. Okay. So there's going to be a lot of algebra here. So unfortunately, there are no quick ways of doing this thing. So let's clean this up first of all, because this and that you can clean it up. So it's going to be 3 over 8. These two put together, and then plus 1/2 of cosine of 2x plus 1/8 of cosine of 4x. Okay, that's this term, and then 1/2 minus 1/2 cosine of 2x. Okay, so this is equal to, you multiply these out. So let's do it like this. This times that. So it's going to be 3 over 16 minus 3 over 16 cosine of 2x. And then we do this times this. So this is going to be plus 1/4 cosine of 2x minus 1/4 cosine of 2x quantity squared. And finally, we're going to do this times that. So let me write on the next line. So plus 1 over 16 cosine of 4x minus 1 over 16 cosine of 4x cosine of 2x. Okay, now all the cosines have powers of 1. Just look. This has a power of 1. This one has a power of 1. This has a power of 1. Yes, of course, they simplify. I understand that. This has a power of 1. So does this, and so does that. The only thing that does not is that fellow. And that fellow, we can use the half angle formula to make it power of 1. So this is equal to, let me use the same color so that you can see what I've done. 3 over 16 minus 3 over 16 cosine of 2x. I didn't do anything with these two. I didn't do anything with the rest. The next one, plus 1 over 4 cosine of 2x minus 1 over 4. The only thing that I've done is use double angle formula to get rid of this. So it's going to be 1 plus cosine of 4x divided by 2. And then the rest I just write. So this one was plus 1 over 16 cosine of 4x minus 1 over 16 cosine of 4x cosine of 2x. In all likelihood, the answer in the back of the book is going to be, they have simplified, for example, these things and, the combined terms. And that the cosine of 4x here that can be combined with that. I'm not going to do that. Please make sure that you can work it out. Let's stop here, and then we're going to go and do the next